In this video, we use the James et al. Dataset to answer the research question: to what extent does reading comprehension differ by age group? To answer this question, we'll use an analysis of variance because we want to compare the three different age groups to one another. Of course, we've already learned about the t-test. We can use the t-test, but because you can only compare two groups in a t-test, we're going to have too much error. And so we use an ANOVA to overcome the effects of multiple testing. In Jamovi, you'll go to the Analyses tab, ANOVA, and then ANOVA. In the course guide, I explain that you can also do an ANOVA using the one-way ANOVA tab on Jamovi. But because an effect size can be obtained from ANOVA, that's the one we'll be using now. So our dependent variable will be reading comprehension. And we use the raw scores because we're going to compare age groups. So if we use standardized scores that are already standardized by age, we probably won't find a difference because you're already accounting for age as a variable. Our fixed factor will be age group. Then it's very important to get effect size, so we'll get eta squared. And you can interpret this the same way as r squared in a linear regression. So it is what proportion of variance is explained by the predictor variables. Navarro and Foxcroft also suggest that omega squared would be a better effect size measure, but because eta squared is more reported, we'll include that. We'll skip over model because we only have one predictor, and we'll go to assumption checks. You want to click all of them. Homogeneity test to see if there's homogeneity of variance. And then our two normality checks, one numerically with Shapiro-Wilk and one through a figure in the QQ plot. And then because we have three groups, we want to do post hoc tests. So you move age group over into the right block. And just to observe, we're going to click no correction, click on Bonferroni and the Holm test. And finally, you should always get an effect size when you do a statistical test. Before we interpret the results of our test, we need to check that the assumptions of the test have been met. According to Navarro and Foxcroft, there are three assumptions for the analysis of variance. These are that there should be homogeneity of variance. So each group should have the same variance or similar variance. The residuals of the model should be normally distributed. And the third one, which you need to check before you run the test, is that all your observations are independent of one another. So you can't have repeated measures when you do a one-way analysis of variance. So let's have a look. If we look at Levene's test, P is greater than 0.1, which means that homogeneity of variance has been met. If we look at the Shapiro-Wilk test for normality, we can see that P is less than 0.001, which means that this is a non-normal distribution. And if we look at the QQ plot, we can see that there is deviation around the tails. But let's say for our current analysis, let's assume that this is normal enough. Right, let's go and look at what information is important to report. So this is our main ANOVA F test. It tests the hypothesis that there's no relationship between the variables. So if age group did not have an effect on comprehension, the P here would be greater than 0.05. However, we see that it's less than 0.001, and so the groups do differ by age. So at least one mean of those three groups is different from the others. And our effect size of eta squared is 0.21. So age group explains 21% of the variance in reading comprehension. You'll have to compare this to the rest of the discipline to see if that is something worth talking about. Right, the next step then is to figure out which group differs. So we do post hoc tests, which are reported at the bottom. We're going to look at the Holm correction for the p-value because that is Navarro and Foxcroft's suggestion. And what we see here is the 6 to 8-year-old group differs from the 9 to 11 and 12 to 13-year-old groups, because P is less than 0.001 for both of them. Cohen's Z is, however, very small. If we look at the 9 to 11 and 12 to 13-year-old comparison, we can see that there's no statistical difference here because P is greater than 0.05. Again, D is quite small. And what we explain in the syllabus is that you report the results of an ANOVA in the text. You're not necessarily going to have these tables. So in the text, you'll want to report the overall test, so the F and the P and the effect size. And then if it is significant, you'll have to do post hoc comparisons with some sort of correction to avoid error. And again, remember always to present effect size for each of your inferential statistical tests.